Hi everyone, good morning. Today we will discuss exercise questions of chapter 9. Okay, and we will also discuss in text questions of this chapter also. Okay, first we will start with in text question and later on we will discuss the exercise questions. Okay, let's start now. In text question: which of the following has more inertia, a rubber ball and a stone of same size? Definitely, more will be the mass, more will be the inertia. More will be the mass of the stone, that's why its inertia will be more. Bicycle and a train, definitely the mass of train will be more, so its inertia will be more. A 5 rupee coin and a 1 rupee coin, definitely the mass of 5 rupee coin will be more, so the 5 rupee coin has more inertia. As the mass of an object is the measure of its inertia, so the object with more mass have more inertia. Okay, got it? Let's move to next question. Now, in the following examples, try to identify the number of times the velocity of the ball changes. A football player kicks a football to the another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. Also identify the agent supplying the force in each case. Okay, let's discuss. Now, the agent supplying force: first player kicks a ball, kicks the football, change in velocity from O to U. Okay, then second player kicks the football towards the goal, velocity changes again. The goalkeeper collects the football, velocity becomes 0, it's not O, it's 0. Okay, then the goalkeeper kicks the kicks it towards a player of his own team, change in velocity takes place again. Okay, so let's discuss another questions. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. When the tree's branch is shaken vigorously, the branch attains motion, but the leaves stay at rest. Leaves stay at rest due to the inertia of rest. The leaves tend to remain in its position and hence detaches from the tree to fall down. Okay, when you suddenly start shaking the branch of a tree, then the leaves may try to be in the state of rest and the branch will got some motion. As a result of that, the leaves will get removed from the tree and fall down. Next question. Why do you fall in forward direction when a moving bus brakes to stop and fall backwards when it accelerates from the rest? Again, the same reason is there. When a moving bus brakes to a stop, when the bus is moving, our body is also in motion, but due to sudden brakes, the lower portion of the body comes to rest as soon as the bus stops, but the upper part of our body will continue to be in motion and hence we fall in forward direction due to inertia of motion. Okay, and the rest will be when the bus accelerates from rest we fall backwards because the bus is in stationary, our body is at rest, and when the bus accelerates the lower part of our body begins being in contact with the floor of the bus come to motion, but the upper part of our body remains at rest due to inertia of rest, hence we fall in backward direction. Got it? That is, in first case it is due to inertia of motion, in second case it is due to inertia of rest. Next question. If action is always equal to reaction, explain how a horse can pull a cart. Okay, we all know to every action there is equal and opposite reaction. This is third law of motion. The third law of motion states that the action is equal to reaction, but they can act on two different bodies. In case of horse exerts a force on the ground with its feet while walking, the ground exerts an equal and opposite force on the feet of the horse, which enable the horse to move in forward direction, and the cart is pulled by the horse. Got it? Next question. Explain why it is difficult for a fireman to hold a hose which ejects large amount of water at high velocity. The water that is ejected out from the hose in forward direction comes out with a large momentum, and equal amount of momentum is developed in the hose in the opposite direction. Hence the hose is pushed backward. It becomes difficult for a fireman to hold a hose with experiences this large momentum. Okay, momentum will act in both directions. One, that is water coming out with large velocity in forward direction, other will act in the opposite direction, which makes it difficult for a person to handle the hose which ejects large amount of water. Now, from a rifle of mass 4 kg, a bullet of mass 50 gram is fired with initial velocity 35 meter per second. Calculate the initial velocity of the rifle. M1 mass of rifle 4 kg, M2 mass of bullet. Convert this into kilogram also. 50 gram equal to 0.05 kilogram. Okay. The velocity V2 of the bullet is 35 meter per second. So we need to find out V1 according to the law of conservation of momentum. Momentum of rifle will be equal to momentum of bullet. Okay, so it is M1 V1 is equal to M2 V2. Got it? Got it? And in this way we can find out the value of V1 by solving the given values after putting in the formula. Okay, so let's move forward. Two objects of masses 100 gram and 200 gram are moving along the same line and direction with velocity 2 meter per second and 1 meter per second respectively. They collide, and after the collision the first object moves at a velocity of 1.65 meter. Determine the velocity of the second object. Very easy to find out. M1 100 gram 0.1 gram, M2 200 gram 0.2 kilogram, U1 U2 V1 V2. Okay, it is very easy to find out. Put all the values in the given formula. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Okay, how we can find out this? Put all the values in the given formulas, and then M1 U1 plus M2 U2 minus M1 V1 upon M2, then we can find out the value of V2 in meter per second. Got it? Let's move further. An object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with a non-zero velocity? If yes, state the condition that must be placed on the magnitude and direction of the velocity. If no, provide a reason. Okay. When an object experiences a net zero external unbalanced force, in accordance with second law of motion, its acceleration is 0. Okay, F is equal to ma. If F is 0, then m can't be 0, so a will be 0. If the object was initially in a state of motion, then in accordance with the first law of motion, the object will continue to move in the same direction with same speed. It means that the object may be traveling with a non-zero velocity, but the magnitude as well as the direction of velocity must remain unchanged or constant throughout. Got it? Let's move to next question. When a carpet is beaten with a stick, dust comes out of it. Explain. The carpet with dust is in the state of rest when it is beaten with a stick. The carpet is set in motion, but the dust particle remain at the rest. Due to the inertia of rest, the dust particle retain their position of the rest and falls down due to gravity. Got it? Why is it advised to tie any luggage kept on the roof of a bus with a rope? Okay. In moving vehicles like bus, the motion is not uniform. The speed of the vehicle varies and it may apply brakes suddenly or takes sudden turn. The luggage will resist any change in its state of rest or motion due to inertia, and this luggage has the tendency to fall sideways, forward or backward. Got it? To avoid the fall of luggage, it is tied with a rope. Got it? Similarly, if you do not apply seat belt, the same will be the case with you as the luggage. Okay, let's move further. A batsman hit a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest. The ball slows to a stop because the batsman did not hit the ball hard enough. The velocity is proportional to the force exerted on the ball. There is a force on the ball opposing the motion, that is force of friction. There is no unbalanced force on the ball, so the ball would want to come to rest. Very bad. Option C will be right answer. Opposing force will act in the against the motion of the ball, that is force of friction. Okay, so option C is the right answer. A truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7 tons. 7 ton, 1 ton is equal to 7 ton. Okay, it is equal to 1000 kilogram. So it starts from rest, so its initial velocity u will be 0. U is 0. S is 400 meter. T 20 seconds. M is given there. It will become 7000 kilograms. Okay, so here we should use second equation of motion. S is equal to ut plus half at square. Got it? From there, first we will find out the value of acceleration A. S is equal to ut plus half at square. Put the values of u, s, t. Okay, then find out the value of A, and then after calculating the value of A, use the formula for force. F is equal to m into A. M 7000 it is given there, and the value of A that is calculated from equation second will be used over here, and the force will come into Newton. Okay, let's move further. A 8000 kilogram engine pulls a train of 5 wagons, each of 2000 kilogram, along a horizontal track if the engine exerts a force of 40,000 Newton and the track offers a friction of 5,000 Newton, then calculate the net accelerating force, the acceleration of the train, the force of wagon 1 on wagon 2. Okay, let's find out. The net force accelerating force is force exerted by the engine minus frictional force. It is 35,000 Newton it will be. Okay. Next is the acceleration of the train. A is equal to question mark. M is given there. Mass of 5 wagons pulled by the engine 10,000 kilogram. Then force is given there 35,000 Newton. Here you can easily find out the value of A. It will be 3.5 meter per second square. Got it? Now the force of wagon 1 on wagon 2. Mass of wagon 2 2000 into 4, it is 8000. A is 3.5 meter per second square. So F is equal to M into it is 28,000 Newton. Got it? Let's move to next question. An automobile vehicle has a mass of 1500 kilogram. What must be the force between the vehicle and road if the vehicle is to be stopped with a negative acceleration of 1.75 meter per second square? Okay, mass 1500 kilogram. A, negative means retardation we can call it. Okay, so it is minus 1.75 meter per second square. Now we can find out the value of force easily. It is by multiplying both the values, minus 2550 Newton. The force between the vehicle and the road is minus 2550 Newton. Negative sign shows the direction of force in the opposite direction. Okay, let's move to next question. What is momentum of an object of mass m moving with velocity v? Options are mv square, mv square, m square v square, mv square, half mv square, mv. It will be m into v. Option D. As we studied, momentum is equal to p is equal to mass into velocity. Using a horizontal force of 200 arc, we intend to move a wooden cabinet across a floor at a constant velocity. Okay, why is the frictional force that will be what is the frictional force exerted on the cabinet? Obviously, as the wooden cabinet moves across the floor at a constant velocity with a force of 200 Newton, as the frictional force that will be exerted on the cabinet will be less than 200 Newton. That's why it is possible to move the cabinet in the forward direction. Next question. The two objects each of mass 1.5 kilogram are moving in the same straight line but in opposite direction. The velocity of each object is 2.5 meter per second before the collision during which they stick together. What will be the velocity of the combined object after collision? The mass of the object m1, m2 is equal to 1.5 kilogram. Velocity of object 1 v1 2.5 meter per second. Velocity of second object v2 minus 2.5 meter per second. Momentum before collision m1 v1 is equal to m2 v2 is equal to 0. Okay, is equal to 0. So momentum after the collision m1 plus m2 is equal to 1.5 plus 1.5. Okay, after collision the velocity will be v according to the law of conservation of momentum. The momentum before collision and momentum after collision, it is 0 before collision and after collision it will also be 0. Got it? According to the third law of motion, when we push on an object, the object pushes back on us with an equal and opposite force. If the object is massive, truck parked along the roadside, it will probably not move. A student justify this by answering that the two opposite and equal forces cancel each other. They comment on this logic and explain why the truck doesn't move. The mass of the truck is too large and hence its inertia is too large or high. The small force exerted on the truck cannot move it and the truck remain at rest. For the truck to attain motion, an external large amount of unbalanced force is needed to be exerted on it. Okay, but for the movement of truck we must apply more force, more unbalanced force, that is more than that the mass of the truck. Okay, a hockey ball of mass 20 to 100 gram traveling at 10 meter per second is struck by a hockey stick so as to return it along its original path with a velocity at 5 meter per second. Calculate the change in the momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. Mass, we all know it's 200 gram, 0.2 kilogram. Initial speed 10 meter per second, final speed minus 5. High initial momentum mu, final momentum mv. Change in momentum, very easy yaar. Change in momentum equal to difference in momentum, 2 minus 1, it is 3 kilogram meter per second square. Got it? Let's move further. A bullet of mass 10 gram traveling horizontally with the velocity 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 seconds. Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of the force exerted by the wooden block on the bullet. Got it? The penetration of the bullet in the wooden block is 2.25 meter per second. We need to find out distance. Okay, we are given with velocity as well as time is also given that. So using the formula velocity, v is equal to s by t. We need to find out s, it is, then we can find out the penetration distance easily, and then force will can be calculated over there. 10 gram mass is given there, convert this into kilogram, and we are given with velocity and time also. We can find out acceleration with the help of that, and then putting the value of mass as well as acceleration we can easily find out force. An object of mass 1 kilogram traveling in a straight line with a velocity of 10 meter per second collides with a stick to a stationary wooden block of mass 5 kilogram. Then they both moved off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. M1 1 kilogram, V1 10 meter per second square. Mass of wooden block 5 kilogram, that is M2. Then M2 will become 5 kilogram plus 1 kilogram, it is 6 combined object, 6 kilogram. Velocity of the combined object v2 we need to find out, p1 and p2. Momentum before impact m1 v1, it is 10 kilogram meter per second. Momentum after impact is equal to, before and after both will be equal. Okay, then we can find out the velocity also. Velocity easily, that is v2, m1 v1 is equal to m2 v2. We can easily find out this. Next question. An object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. Calculate the initial and final momentum of the object. Also find the magnitude of the force exerted on the object. M is equal to 100 kilogram, U is equal to 5 meter per second, V is equal to 8 meter per second, T is equal to 6 seconds, P1 M1 MU is equal to P1 P2 MV. Okay, final F is equal to change in momentum upon time. Okay, initial momentum, final momentum. So change in momentum is 300 upon it is 300 upon 6 into 100. Okay, mass 100 kilogram into change in momentum, it is A upon T. A is will be change in momentum here, V minus U upon 80. 300 into 300 upon 6. Okay, then it is 100, 300, 550. It is 5000 Newton will be the force exerted on the object. Okay, this question is a theoretical question, so read out these questions and try to find out the possible solution. Okay, it is based on the initial momentum before collision and final momentum after collision. The equal force is exerted on both the bodies, but the mass of the insect is very small. It will suffer greater change in the velocity. So next question, how much a momentum dump will a dumbbell of mass 10 kilogram transfer to a floor if it falls from the height of 80 centimeter? Take its downward acceleration to be 10 meter per second square. Small g, m mass is given there, h is given there, a is given there, u is 0. Then use third equation of motion to find out v. It is v square minus u square is equal to 2as. V will be 4 meter per second. Then the momentum is mass into velocity. 10 into 4, it is 40 kilogram meter per second. Got it, dear students? So in this way we did a solution of the exercise questions as well as the in-text questions. In our next class, we will discuss some extra questions of this chapter. So dear students, do one thing. Do the solution of all these questions in your notebook. If any doubt is there in any questions, you can admit your queries straightforward on my personal account. Okay dear students, till then,